Let us consider the modal dispersion, how it takes place. When numerous waveguide modes are propagating, they all travel with different net velocities with respect to the waveguide axis. An input waveform distorts during propagation because its energy is distributed among several modes, each traveling at a different speed. Part of the wave arrive at the output before other parts, spreading out the waveform. So this is thus known as the multimode dispersion. Multimode dispersion does not depend on the source line width. That is, even a single wavelength can be simultaneously carried by multiple modes in a waveguide. Multimode dispersion would not occur if the waveguide allows only one mode to propagate. The advantage of the single mode waveguide is that single mode waveguide or single mode fiber does not allow the higher order modes to propagate through it. Now if you consider, just for an example, three different modes, m equal to 0 inside the multimode fiber, m equal to 0, the basic uh, angle of incidence is phi 0. This is m equal to 1, it is little bit tilted, so angle is phi 1, and for m equal to 2, it is further tilted, so it is phi 2, angle is phi 2. So actually, mode the modes, mode is the zigzag path, right? Mode the value of mode means mode the zigzag path. Now suppose we transmit a low bit rate of 10 MB per second. So pulse duration is nearly 100 nanosecond. So each pulse will spread up to nearly 100 nanosecond every kilometer. This is just an example. The broadened pulse overlap, right? And intersymbol interference takes place. So modal dispersion limits the bit rate of optical fiber link. This is of the order of 10 Mbps. Uh, a coaxial cable support this bit rate easily. So why you are going for optical fiber, right? So that's the problem. Bit rate distance product. So if we multiply the bit rate with the distance, uh, it is called the bit rate distance product. So that can be estimated in this way: 2c n core divided by n square. N is the numerical aperture. So this condition provides a rough estimate of the fundamental limitation of step index multimode fibers. The smaller is the numerical aperture, the larger is the bit rate distance product, right? For single mode fiber, what will happen to the modal dispersion, right? For single mode fiber, it is actually allowing only the one mode to propagate. So main advantage of single mode fiber is to propagate only one mode, so that modal dispersion is absent. But does it mean that since there is no modal dispersion, the optical fiber, single mode optical fiber is free from dispersion? The answer is no. The pulse broadening does not disappear altogether, right? For single mode fiber, the group velocity associated with the fundamental mode is frequency dependent within the pulse spectral line width because of chromatic dispersion. So though inside the single mode fiber, the multimode or modal dispersion is absent, but chromatic dispersion will be there. So another kind of dispersion mechanism uh, controls the total overall dispersion inside the single mode fiber, right? For multimode graded index fiber, as we have already seen that the amount of dispersion is lesser. Let us see how exactly it is happening. For graded index fiber, the refractive index varies for alpha equal to 2, that is for parabolic profile, n1 into 1 minus twice delta r by a whole square to the power half for core, inside the core. And for cladding, we have n1 into 1 minus twice delta whole to the power half. This is for cladding right here. So as you can see, when the wave goes from axis towards the periphery, towards cladding, the refractive index is actually diminishing, right? So at every point, the wave is actually going from denser medium to rarer medium, right? So at every point, the refraction takes place, right? And the refraction takes place in this way that it is going from denser medium to rarer medium. So wave will tilted towards the axis, right, as it passes. So gradually the wave will be tilted and finally it will reach to a particular point where the condition for critical refractive index, that is the critical condition, will be reached, right, and the total internal reflection will take place. So the wave will go towards the axis, right? But during this journey again, the wave will pass at every point, the wave will pass from rarer to denser medium, right? So it will move towards the normal direction, right? So ultimately it will come to this point. Same thing happened to the other modes, right? Same thing happens. So what happens, actually what happens, the wave will not going up to the cladding, rather the internal reflection takes place within the core itself, right? And all the modes will ultimately meet at a particular point, right? And this thing is repeated. This thing is repeated. All the modes will meet at this point again, right? So because of this multiple focusing arrangement, because of the change in refractive index profile, that actually reduce the pulse broadening. Okay, because all the modes are coming to this point in equal time, right? Because there is a focusing arrangement, right? That is why for multimode graded index fiber, the dispersion, effect of dispersion is much lesser compared to the multimode step index fibers.